So if you do a series of transformations, you might have your function. There might be one point on it that you're interested in, and you want to know what's happened to that point after it's been stretched and then translated and then reflected and all kinds of other things. There is a way, no matter where the point is. This one has been reflected across the x-axis, vertically stretched by a factor of 1/3, and then translated 7 units right. At the end, okay, so they don't tell us where it starts, only where it ends up. And they don't tell us anything about the original point, so they're making this difficult for us. Our original point, I'll say, is at x, y. This means I don't know a single thing about it. I'm just writing that it's got an x coordinate. Someday I'll know what it is. It's got a y coordinate. I may find that as well, but for the moment I know zilch. Now, if we reflect that point across the x-axis, meaning we reflect it vertically, the effect that has is, well, it has no effect on the x-coordinate. Vertical things never do. But the y-coordinate is going to become negative y. If you do a vertical reflection, that means anything that used to be 5 feet up is now 5 feet down, and so on like that. So whatever our y-coordinate was, we now have the negative version of it. Now we do a vertical stretch by a factor of 1/3. Again, because that's vertical, it does nothing to the x-coordinate, but it multiplies our y-coordinate by 1/3. So instead of minus y, we now have minus 1/3 y. And finally, they move this 7 units to the right, as in horizontally. If you move something horizontally, then or 7 units to the right, then its x-coordinate goes up by 7. So instead of plain old x, we now have x plus 7. And horizontals do nothing to the y-coordinate, so this is still minus 1/3 y. All right? So original, it gets reflected, it gets compressed, and then it gets shifted 7 units to the right. Now, this still isn't much help. It still contains variables, but they've told us that our point ends up at 1 comma something, which means this coordinate is 1. If x plus 7 is 1, then x must be 1 minus 7, negative 6. Fair enough? Well, if x is negative 6, and we know that our function is y equals x squared, that must mean y is negative 6 all squared, 36. Now we're getting someplace. This coordinate was 36, which means our new coordinate must be minus 1/3 times 36. So it must be, sorry, I'll put y equals on this. Minus 1/3 times y, which is 36, must be minus 12. So our new point is at negative 6. Or sorry, the original point was negative 6. The new point is 1 comma negative 12. The original point would have been minus 6, 36. So we worked backwards, got our x. That tells us where our starting point was. This is the start. And after those transformations, 1, negative 12 is the end. So state the coordinates of the vertex of the final graph. If we had y equals x squared for our original parabola, where's the vertex then? It would have started at 0, comma 0. So now we just do these transformations again, and let's see what effect they have. We reflect it in the x-axis. That does nothing to our x-coordinate. It turns this from 0 to, well, negative 0, which makes no difference at all. Vertical stretch, we multiply our y-coordinate by 1/3. So 0, comma 0 times 1/3 is 0. Still no effect. And now we move 7 units to the right, which means our x-coordinate goes up by 7. The new vertex should be at 7, comma 0. And finally, find the value of t. Oh, lucky us, we got it already. They said the end point was 1 comma t. We found during our investigation that the t is minus 12. That's the y-coordinate where this point ends up. All right, so if you know nothing about a point, you can just call it xy and then apply transformations to it bit by bit until you run across some additional clues.